In order to solve these problems, we have to figure out what the pyramid means. What does it do? What operations does it represent? So let's first look at the examples that are given to us, and we need to think of each one of those as an equation. Look at example A. The answer to example A is 12. So 6 pyramid 0 equals 12. Just as in B, 4 pyramid 3 equals 11. C would be 10 pyramid 1 equals 21, and so forth. Whatever rule we allow the pyramid to stand for, it has to work in each of those equations. So if we look at A first, what operations could the pyramid represent that would allow something to happen to 6 and 0 to equal 12? Well, I know that 6 times 2 equals 12, but what about that 0? Could it be that the equation should read 6 times 2 plus 0 equals 12? Let's see if the rule of double the first number, add the second number, works for all of our equations. 4 doubled is 8, plus 3 is 11, so it works for B. Let's see if it works for C. 10 doubled, or times 2, plus the second number is indeed 21. And now let's try it for example D. 8 doubled, or times 2, plus the second number, which is 3. 8 times 2 is 16, plus 3 is 19. So it works for each of our examples at the top. So pyramid means double the first number and add the second number. Let's now look at the ones on the bottom and see if we can't solve those. I'm going to write our rule right up here just so that we have it to look at. So we're going to double the first number and add the second number. So if we look at number 1 at the bottom and apply our rule, 5 times 2 is 10, plus 0 equals 10. 9 times 2 plus the second number, which is 2, equals 20. Number 3 would be 3 times 2, and we're missing our second number. So we have to go about figuring out how to solve for that. Let's erase this so we have some space. Following our rule, this would be 3 times 2 plus, we'll give it a variable, we'll say A, equals 10. Well, we know that 3 times 2 is 6, so 6 plus A must equal 10. And if we do the inverse operation, 10 minus 6, or if we just think to ourselves 6 plus what equals 10, we will come up with 6 plus 4 equals 10. So our missing number over here would be 4. You can apply the same idea going forward on number 4. This time we're missing the first number that we need to double. So we'll give it the variable this time. We'll call it a. A times 2 plus 7 equals 11. Again, if I do the inverse, I would say that 11 minus 7 is 4. And then I need to think of what times 2 equals 4. And of course that would be 2 times 2 equals 4. So our missing number up here must be 2. And as always, it would be a wonderful idea to check and make sure that I am correct. So I'll apply our rule of 2 times 2 plus 7 equals 11. And 4 plus 7 does indeed equal 11, so it is correct.